This course is all about importing code into your program and the mechanisms Python has for managing groups of code. This is a deep dive, and you'll cover a lot of topics, including all the variations of the import statement, the differences between modules, packages, and namespaces, how to create installable packages, what the import system does when you load a module, the problems with circular imports, how to dynamically load modules, and a way to bundle your code as a runnable zip file. The code in this course was tested with Python 3.12. Much of it has been standard since Python 2, and so almost any version should work. The import lib resources library is covered, which got added in Python 3.7. Anything after that should be good. Once your program reaches a certain size, you don't want it all in one file. You want to organize it and keep similar things together. In fact, even for small programs, it's unusual not to at least import something from the standard library. That import thing is responsible for loading code from modules and packages, which are a hierarchical mechanism for grouping code together. The import keyword has three main variations, allowing you to load a module, load something from a module, and alias the loading thing as well. And also, within those three mechanisms, there are variations, depending on relative and absolute specification of a module name. Once you've got modules and packages, you're likely to want to move them around so you can reuse them. Python has the concept of an installable package, or you can actually stick your code in a runnable zip file. And if all that isn't enough, you can dynamically control the loading of modules. This course covers a lot. You'll learn all the ins and outs of importing, where it can trip you up, and likely some powerful aspects you haven't seen before. Next up, I'll start out by going through all those import variations I just mentioned. In the previous lesson, I gave an overview of the course. In this lesson, I'll walk you through the most common ways of importing modules in Python. If you're building a small program, you tend to put it all in one file, but as your programs get bigger, you want a way to organize them, keeping like things together. A namespace in computer science is an abstract container for the parts of your code. A namespace might contain variables, class, or function definitions, all with the idea that if I call my function getName and you call your function getName, we don't have to worry that we've used the same name, as long as we have different namespaces. Python mostly uses directory structure to define these kinds of groupings, and it uses the term module for one of the lower levels of this kind of container. It typically corresponds to a single Python file. A package, on the other hand, is a recursively defined structure rooted at a directory which can contain modules and more directories. You indicate that a directory is a package in Python by including a file with a special name, _init_.py, often pronounced dunderinit.py. Packages form the backbone of code reuse and can be bundled up for sending to other people. Python also has an extra mechanism that is similar, known as a namespace package. This is like a package, but is dynamically created, meaning you can have multiple directory structures with the same paths and treat them as a single thing. One thing to note about all this vocabulary is that in the real world, people often misuse it. You will frequently hear folks use the term module and package interchangeably. In fact, I tend to only use the word package when I mean a third-party bundle, and frequently miscall packages in my own structures modules. It isn't strictly correct, but it is quite commonplace. Python ships with many modules and packages which you can take advantage of, and PyPI is a central repository for third-party installable packages and is one of the reasons Python is so popular. There's a package for pretty much everything. The import keyword is what brings a module or package into your namespace. If you're writing Python in a file, the import keyword imports a module or package into the namespace scope of that file. Or, if you're using the REPL, it imports it into the general namespace of the REPL. Speaking of the REPL, let's go there and look at some of the more common types of importing. Before importing anything, I want to introduce you to a built-in function called dir. The dir function lists everything in the current namespace. Let me try it out. The default Python namespace already has some stuff in it, but as you'll note from all those double underscores, it's internal stuff. So that's what the almost empty namespace looks like. Let's import something. You use the import keyword to import a module or package, Okay, let's just get this out of the way now. I'm going to stop saying module or package every time. Remember when I said I tended to use these terms loosely? Well, loose usage is in your future. What running this command has done is import the math module into the current namespace, which is the REPLs namespace. I can reference things inside of the math module using dot notation. The math module contains some constants that are commonly used in math, like pi. Using dot notation like this, I can get at all the things in math. So just what did importing math do to the namespace? It still has all those dunder things, but the namespace also now has math tacked on at the end. The dir function optionally takes arguments. You can pass it a module that you've loaded to see what's in the module's namespace. Math has a lot of stuff in it, including pi, the constant I displayed earlier. In addition to importing a module, you can import things from a module. This notation says to import all the things inside of the math module into the current namespace. Generally, this isn't considered good practice as it clutters your namespace up. See? The top-level namespace now has all the dunder stuff as well as all the stuff from math. The more you do this, the more likely you're going to get a name collision. Python allows name collisions. It does shadowing, meaning the last thing defined is what is currently defined. More on that later. But for now, realize that the more things you have in the namespace, the more likely you have clobbered something and won't be sure what you're actually using. The more common way is to import just the thing you need. The calendar module has constants for each month of the year. This last statement has imported only the January constant. And since I used the from format, I don't need the module name to use January. I just use January. In fact, I can't even use calendar. I didn't import it. I imported January from it. Depending on what version of Python you're using, you'll get different error messages here. I'm using Python 3.12, and the last couple of releases have added more helpful errors. This one even guesses at what I'm trying to do. And although when I look at January in the REPL, it says it is calendar.january, it actually hasn't been imported like that. It has to be January on its own. You can also rename things when you import them using the as format of the import statement. Here, I've imported the CMath module, but I've renamed it complex instead. Like with math, CMath also has constants in it. This is similar to what I just did with math.py, but this time I'm using cmath.tau after aliasing cmath to complex. You can combine the from syntax with aliasing. Here, I've imported the min-year constant from the datetime module and aliased it as the more readable min_year. And like with January, I use it directly. Python dates don't do before common era. The minimum year is 1. Did anyone call FedEx? It's time to talk packages. Use of the term FedEx or its counterpart Federal Express is not meant as an implicit or explicit sponsorship of FedEx. Real Python and its affiliates have no relationship with FedEx. Any product names, logos, brands, or trademarks belong to their respective holders. Prolonged use of fine print disclaimers can cause nausea and heartburn. Before trying a disclaimer, you should consult a doctor. Your mileage may vary. You must be this tall to ride the whooping Viking. In the previous lesson, I showed you the variations on the import statement. In this lesson, I'll be diving deeper into how packages work in Python. A package in Python is a directory containing a dunder_init.py file. When you import a package, submodules or subpackages do not get imported by default. But a dunder_init.py file is still a Python script, and one of the things you can do inside of it is import submodules or subpackages into the parent namespace. You might do this to expose specific interfaces as an API to developers using your package, without them having to know where the interface lives within the submodules of your package. Let's look at some packages to see how they work. In the top window, I'm showing the directory structure of a package named Africa. You can tell that it's a package because it contains a dunder_init.py file. In this case, that file is empty, but having it there indicates to Python that this is a package. Inside the Africa directory is Zimbabwe, a Python file, which is a submodule inside the Africa package. Let's look at Zimbabwe. This module contains a hello world print statement. All right, let me use the REPL and play with the package. I'll start by importing Africa. If you examine Africa in the REPL, Python tells you that it's a module. Note that although I've got a package structure, what Python really is interested in is the dunder-init.py file. The directory is almost secondary. Technically, you don't load a package, you load a module in the package, and that module, if the thing being imported is the directory name, is the dunder-init.py file. Remember when I said submodules and subpackages don't get loaded by default? Although Zimbabwe exists inside Africa, it has not been imported. The dunder-init.py file is empty. It doesn't contain anything named Zimbabwe, and hence you get an attribute error. If I want Zimbabwe, I have to import it explicitly. And notice here that I didn't import Zimbabwe, I imported africa.zimbabwe. So trying to use Zimbabwe on its own is a name error. If I use the fully qualified name, I can see that this is also a module. With me so far? Let's make it a little more complicated. This is another package, this time called Europe. It is structured similarly to Africa in that it contains a dunder-init.py file and a single module. But this time, I've put some code in the dunder-init.py file. The code imports the Greece module into the namespace. The dot here is called a relative import and means to look for the module in the current directory structure. This mechanism isn't actually recommended, and I'll talk more about that later. Since dunder-init.py gets run as part of the module loading process, importing Europe will have two side effects. First, it imports Greece, and second, it prints a message. And this is greece.py, which has its own message. Let's try importing Europe. When you import Europe, you can see that it imported greece.py, since importing that module prints out the Greek message. Note that the inside Europe dunder.init py message comes after the Greek message because Europe's dunder.init.py imported greece.py first. And since Europe imported Greece, I can access the europe.greece module. Note, I can't get at Greece directly. You can do a different import to bring Greece in, but that's not what I did here. All right, ready to make it more complicated? The last package I'm going to show you is the Americas continent. It has a dunder.init.py file, which is empty, like Africa's was, and a subpackage. You can tell that North is a subpackage because it also has a dunder.init.py file, and it has two modules, Canada and USA. As I'm Canadian myself, you can probably guess what jokes are coming next. The dunder.init in the North subpackage is not empty. It imports Canada, like how Europe did with Greece. It also prints a helpful message. This is the Canada module. What, you thought the joke would be anti-American? Nope. Us Canadians are, one, more polite than that, and two, tend to prefer a self-deprecating flavor of humor. That's flavor and humor with a U. And finally, this is the USA module. Did you know that although y'all is considered plural, it's considered a small plural? When addressing a particularly large group, you modify it with all y'all. The hard part about that little fact is if you're not American, you probably think I'm joking. Let's import North from the Americas package. As North's dunder.init.py file imports Canada, you get the message from the canada.py module and the message from North's dunder.init.py. North is a module, and since I imported it using the from syntax, I can use it directly, even though its fully qualified name is americas.north. And because loading North had the side effect of loading Canada, I can get at north.canada as a module. I cannot do the same for the USA, as although it is a subpackage, it hasn't been imported. I also can't import north.usa, as that isn't the name of the module. I have to use the fully qualified name in order to get it. And like before, because I imported the fully qualified module name, I can't use USA on its own. But interestingly, I can now reference north.usa. Loading USA has put it in the namespace, and north is already there, so Python knows how to reference this now. I can also get at it using the fully qualified form. Namespaces are all about trying to reduce your name conflicts. So what happens when your namespaces conflict? Next up, I'll show you module shadowing. In the previous lesson, I showed you the various ways submodules and subpackages can work when you import their parents. In this lesson, I'll show you what happens if you load two modules with the same name. Variables in Python aren't like variables in some languages. They aren't a box containing something. They're a reference to an object. When you construct a string or create an integer, the variable you're defining is actually a reference to a string object or an integer object. At any time, you can create a new reference in the namespace that has the same name as the old reference, but points to a different object. This overrides the original definition, sometimes known as shadowing it. For simple variables, the thing being shadowed can't be recovered unless you squirreled it away in another reference. But you can shadow built-in objects like functions. You can redefine print if you really want to. If you do shadow print, you can then get the original back by deleting your reference. Python lets you override built-ins, but doesn't let you get rid of them, so you can't delete the original print. Everything in Python is an object. Man, if I had a nickel for each time I've said that, I'd have at least one nickel, wouldn't I? Modules are no different. They're objects too, which means they also can be shadowed. Most of the time. Let's go play in the shadows. I've created a Python file named random.py. Inside, it has a single function that returns a random number. It isn't a very good random number. That's not the point. In case you're not aware, Python's standard library has a module with the exact same name as this file. Let's import this. Python doesn't care. It happily imports my local copy. I'm thinking of an integer between 1.9 and 2.1. Can you guess it? How'd it do that? See, no problems calling getRandom and getting its response. The standard library's random module has a function called randint. Let me import that. And that's shadowing in a nutshell. Python will only ever load a module once. So by loading my local version of random, it's defining that module in the namespace. When I try to import something from the standard library's random module, it sees random as the existing module, the local one, in the namespace. As it only has getRandom and no randint, this is problematic. Thankfully, the error message is much improved. In older versions of Python, it simply told you there was no such thing to import, and so if there was a misnamed Python file in your directory, shadowing a built-in, you could pull your hair out trying to figure out why a standard library function couldn't be found. I've had this happen to me enough times that I finally learned the likely culprit. The new version of the error includes the name of the module file, making it much more obvious as to what's going on. Score 1 for improved error messages. Not all modules can be shadowed. Let's look at another one. In the top window, I've created time.py. Like with random.py, this has the same name as a built-in module. Let's load this one. There's the import. Ooh, wait a second. Where'd my function go? Time can't be shadowed. Unfortunately, this is that error I was just complaining about, but in the other direction. It can leave you scratching your head. Why can't it find my function? It's right there. A poor developer could go bald. Let's look at the difference between these two modules to see what's going on. Evaluating my local random module in the REPL shows you that it's a source file, whereas time tells you it's built in. Through the magic of video editing, I've exited the REPL, started a new one, and tacked it onto the bottom here so you can see it. I also changed directories so that my shadowy random.py isn't there anymore. To see the difference between time and the standard library's real random, let's import it. And evaluate it. That's a very long chunk of output thanks to how Python gets installed on Mac OS. The important thing to notice is that it ends in random.py. Modules in Python's standard library can be Python files, just like your Python files, but they can also be precompiled binaries. Time is a precompiled binary, so it shows up as built in. Precompiled binaries get looked for first when you call import, whereas those Python file types, they get looked for in the order specified by the module search path. The module search path includes the current directory before the system directory, so it finds my local random.py and allows the shadowing. So that's why random can be shadowed, but time cannot. I'll show you more on the system path that tells Python where to look for modules in a later lesson. To share packages with others, they can be bundled up and made installable. In the next lesson, I'll show you the structure of just that kind of package.